All right, so we are going to move on to chapter 8, which is on linear regression. This essentially picks up where we left off in chapter 7. So, in stats, on a scatter plot, once we have a scatter plot, we could also do something called a regression line or a trend line. So remember, a scatter plot is just a plot of your x and your y variables. And a regression line or a trend line is a line that describes how a y variable responds to changes in the x variable. Essentially, we use the data that we have in the scatter plot to create an equation, and then we use that equation to make predictions of what we think might happen based on the data that we have. So, our general form of a regression line, and I should say this is a linear regression line, might look a little familiar to you. The variables are a little different, but you might remember in Algebra 1 or Integrated 1, or even back in middle school, you learned about slope-intercept form. Slope-intercept form was originally probably presented to you as y equals mx plus b. Basically the same thing here, except we're using ax plus b instead of mx plus b. Or we could reverse the order like I have it here. Either way, the y is the value, is our predicted value. Like I said, we use the equation of the regression line to make predictions. The a value, the coefficient of the x term, is the slope. So no matter where that term is, the coefficient of the x term is the slope. So it tells you how y changes as x increases. So if you have a positive slope, that means y will increase as x increases. If you have a negative slope, that means y will decrease as x increases. And the graph will be a negatively sloped graph. The b value, just like when you originally learned sloped intercept form, the constant term, meaning it has no x attached to it, is called the y-intercept. Y-intercept is where the graph or crosses or intersects the y-axis. In this case, the y-intercept is the value of y when x equals 0. So is what we predict our y value to be when x is 0. So that is what a regression line is. We'll talk about how to actually calculate, how to figure out the equation of a regression line in a few minutes. Now, like I said, a regression line is used to make predictions. Now, sometimes our predictions will match up with what actually ends up happening, and sometimes our predictions won't match up with what we think is happening. And when the predictions don't match up with what actually ends up happening, we have what we call a residual. So a residual is the difference between the actual y value and the predicted y value. Okay? It's our actual y value subtracted our predicted y value. So whenever you have a difference between what actually happened and what you thought would happen, it's what we call a residual. So if you have a positive residual, that means what actually ended up happening was greater than what you thought, what you predicted would happen. If you have a negative residual, it's the opposite. So a negative residual means what actually ended up happening was less than what you predicted would happen. And a 0 residual means they're equal. That means that what you predicted would happen actually ended up happening. Okay. So A residual is just simply that difference. Okay. The last thing, the last main topic in this chapter is comparing standard deviations, which is what we talked about in chapter 6, the z-score, comparing that to correlation, which is what we talked about in the last chapter. Okay, so this is how we compare standard deviations and correlation. If an x value is increased or decreased by a certain number of standard deviations, and remember, a number of standard deviations is the definition of a z-score. So if an x value is increased or decreased by a certain number of standard deviations, then the y value will be increased or decreased by that number of standard deviations times the correlation coefficient. So the y value will be increased by that number of standard deviations, which is the z-score, times the correlation coefficient, which, remember from last chapter, correlation coefficient, we traditionally use the variable r to describe that. So what do I mean by this? I will show you through this example here. Okay. In the last chapter, we learned about how to calculate correlation on StatCrunch. So the correlation between the price and size of a home, is 0.8. What would you predict about the price of a home one standard deviation below the average in size? And what would you predict about the price of a home two standard deviations below the average in size? So, one standard deviation below average. So, in terms of z-scores, one standard deviation below average or below the mean, it means our z-score is -1. Okay. One standard deviation, okay, below means it's negative. Okay. So we're going to use that formula from the previous slide. Z-score times R. So -1 times 0.8, that's easy. I get -0.8. Okay. Now what does that actually mean? Okay. To answer the question, what would you predict about the price of a home one standard deviation below the average in size? That means that the price of the home will be 0.8 standard deviations, okay, 0.8, and the negative means it's below average. So the price of a home will be 0.8 standard deviations below average, okay? Notice I gave my answer here as 0.8. I didn't write -0.8 standard deviations below because the word below implies that it is indeed negative. And the second part of that question, same question, except what would you predict about the price of a home two standard deviations below average in size? So just like before, two standard deviations, okay, that means my z-score is either going to be 2 or -2. The word below makes the z-score negative. So two standard deviations below average means the z-score is -2. And once again, I use the same formula, z times r, so -2 times my correlation of 0.8, and I get -1.6. So that means that the price of a home will be 1.6 standard deviations below average. So price of the home will be 1.6 standard deviations below average. Okay, so that right here, okay, that essentially shows you what this slide means in terms of an example. You will see at least one example similar to this in your Math Excel assignment on this chapter. Okay. Now, in terms of our regression line, we talked about what a regression line is and what it's used for, but we haven't actually talked about how to figure out the regression line, and we're actually going to use StatCrunch like we always do. And these are the directions here about how you do so. So we go to stat, we go to regression, we go to simple linear, and then you select your x and your y variable. Okay. So stat, regression, simple linear, and then select your x and your y variable. So to show you how it works, we'll do this example. And again, I'm going to do this on StatCrunch. Okay. So I have my data here. And this was just same thing I was talking about before, age and price of a home. Or actually, in this case, it's not the age and price of a home, it's the age and price of a car. And you can see the older the car is, the value of the car tends to be lower, and that's what we would expect. So what I did was I took this data here and I put this data in a StatCrunch spreadsheet. I went on StatCrunch, I went to open StatCrunch, and I put this in one column, and I put this in a second column right next to it. And then I remember I talked about this in the previous chapter, in chapter 7. Once you put this data in, if you click at the top of each column, so if you click at the top of column 1, I could actually title it age. Here I titled it price. So I can go to the top of column 2 and title it price. So I put all that data in StatCrunch, and now I'm going to use that to answer these questions. So find the equation of the regression line using StatCrunch. So to do that, again, I went to stat, I went to regression, I went to simple linear, and this came up. And notice my x variable, because that was my first column, I chose as age. And notice my y variable, I chose my second column, which was price. All right. And I put that in, I hit compute, and this came up. And there's a whole lot of stuff there. But what you want to look at is the 1, 2, 3, fourth line down. The fourth line down actually tells you the actual equation of the regression line. So this right here is the equation of the regression line. Now, if we were actually doing this on Math Excel, you would want to make sure that you round to the appropriate number of decimal places. If it says to round to 2, make sure you round it to 2 decimal places. 3, make sure you round it to 3 decimal places. But this equation right here, again, the fourth line down after you hit compute, will actually give you the equation of the regression line. And that was the only thing you had to do for part A. Okay. What is the slope? And explain the meaning of it. Okay? As I explained earlier, when you have your regression, your equation, the coefficient of the x variable is the slope. So in this case, the coefficient of the x variable is this one right here, negative 959. Okay. Notice it's a negative slope. Okay. So this means that as the car gets older, as it increases in age, the price will decrease by $959 for each year it gets older. Okay, and that would make sense. As our cars get older, they decrease in value. So we would expect that the slope in this case would be a negative slope. Now, if this number right here is the slope, then for the next part, the y-intercept, that would mean the other number, the 14,000 number, would be the y-intercept. Okay? Remember, the y-intercept is the value of y when x equals 0, n is the constant term. Okay, so this number doesn't have an x or age attached to it. It's a constant term. So that is your y-intercept. Okay, so this means that when the age of the car is 0 years old, the price is $14,286. Okay? In other words, the price of a brand new car is $14,286. Okay? If a car is 0 years old, that means it's brand new. Okay. What does the model predict the price of a 10-year-old car to be? Okay. Well, if I want to know what my predicted value for a 10-year-old car, all I do is I plug in 10 for age. And I plug it in and I calculate it, and you can see I get a value of $4,696. Okay, so it's getting older, so the value is going down. It started at 14,000 and it went all the way down to $4,696. How did I get that? I simply plugged in 10 for age. Okay. You have a chance to buy one of two cars. They are both about the same age and appear to be in equally good condition. Would you rather buy the one with a positive residual or the one with a negative residual? Okay, so this goes back to a few slides back towards the beginning. We talked about the residual. The residual is when we have a difference between what actually happens and what we predicted to happen. In this case, the residual will be the difference between the actual price of the car and what we predicted the price of the car would be. So that means if my car has a positive residual, that means the actual cost of the car is going to be more than what we predicted it to be. So a car with a positive residual costs more than what we would predict it to cost. And then conversely, a car with a negative residual will cost less than what you predicted it to be. Okay? So the key is they're the same age and they're in equally good condition. So the question is, the question is really asking, do you want to pay more than you thought it would be, or do you want to pay less than what you thought it would be? Obviously, you want to pay less than what you thought it would be, which means you would prefer to buy the car with a negative residual, assuming it's the same age, assuming it's in the same condition. You'd rather pay less than what you predicted it to cost. So I would rather buy a car with a negative residual. Okay. And that is it for your notes on chapter 8. Okay. There will be some examples on your Math Excel assignment where you will have to use StatCrunch. So obviously go back to the different sections of the video where I talk about this or reach out to me for help.